Yes, okay. So I will try. I have 15 minutes. It's quite tough to go through to all this information for this project we have done some years ago. It's actually one of the maybe I think the first public retrofit in Spain, where we done the project following the EnerPhit protocol. The Passive House Institute also is auditing actually this project. The building has been constructed 2 years ago, and we had the municipality also which organized the monitoring campaign last year. Unfortunately, it stopped with the Corona pandemic, but I think we can see some nice, interesting results. You can see the building from it's originally from the 70s. So I suppose that in the US also you have similar kind of public buildings with no insulation, and as you can see, with simple glasses and very basic window components. So we've done a blower door test. We normally do this also, of course, before the retrofitting of our buildings, and we had in this case really one of our worst results. We had a 17 and 50 value, which was quite very high value. You can see in the images, you can have an idea of all the performance of this building, which had a very low comfort scale. In summer, the teacher complained about very high temperatures, nearly clearly above 30-35 degrees sometimes. Here you can see an analysis of the energy consumption of the building. It's interesting because this building is on the Mediterranean, so it's maybe 2 kilometers from the beach, and one would suppose that the heating is really not an issue in this building. But as you can see, it's 70% of all the energy consumption is driven by the heating demand. In this kind of buildings, there is no active cooling because it's a public school and there is no budget. It's politically difficult to install here active cooling devices. So what we've done is like the basic alphabet of passive house design solutions, like it's called 5 principles, plus of course the sun protection. So we neither hadn't the budget for making, like inventing solar chimneys or something like that. So we concentrated on the, I think you know that, like high insulation thicknesses, windows, passive house certified windows, etc. Here you can see on this floor a typical it was, I think, the first floor plan with the ventilation system. One of the biggest challenges in retrofitting this kind of buildings is the designing of the ventilation system. Because of lack of space, of course, these buildings, the architect in the 70s didn't thought, of course, of installing HRV machines when he designed the building. So you have a building with maybe 40 years of constant usage. So you have to struggle and really to find a place for these devices. And in this case, we designed like a semi-decentralized system with 2 HVAC machines per floor. You can see here a photo of the finished installation. We tried here in this case with textile ducts, which is supposed to have quite good comfort and air velocity, very low air velocity performance. So also they are interesting for maintenance because you can easily wash them in a washing center of the city. Next slide. Here we have section, and you can see the like the air tightness line, and as you may see there is a small problem in this this design, because we couldn't act on the ground floor because of both limitation of the budget of the retrofit, which was from the beginning fixed, so we couldn't act everywhere, and also because of the limited time to do this retrofit, because the school is going on all the months through, and so we only could make the retrofit from ends of June till starting of September. So it was quite a tough schedule to perform in less than 3 months is the retrofit. So we were aware about this problem, and actually the airtightness test, the blower door test, I think the final one was 1.2, so we didn't reach the level of the EnerPhit, but nevertheless I think it is quite a very good result of this retrofitting. Of course, the summer case is a big issue also in this kind of usages in the Mediterranean, in this hotter climate or warm climate. So we have designed 2 barriers of exterior sun protection. We had fixed louvers, vertical louvers, as you may see here in this simulation. With this, we want also to not only to reach a very high energy efficiency, but also get an attractive and friendly character of the building. It's not so easy, of course, to just perform with exterior insulation with the attics system on the outside of the building if you don't consider architectural and aesthetic things. So it could be easily get a quite bad result aesthetically, and I think passive houses also has to have to get this high quality on architecture. So here we've made it's more in this case a theoretical comparison between the EnerPhit standard and which is the green line, and then you see the blue line, which is the baseline, the actual Spanish building regulations. So just to see, it was like the overcost, the real overcost has been about 13%, and also the payback time, it's one of the ways to analyze this kind of maneuvers, was also 13 years. The total costs without the VAT, more or less 800,000 euros. I'm not aware about how many dollars, sorry, but I think it's easy to make the comparison. And at the end, it's typical in the retrofitting that you have surprises during the execution. So at the end, we ended up by, I think, 1 million of euros, and then the VAT, which in Spain is depending in retrofitting, it's 5% of the work you have to pay for the municipality. Some photos of the execution on the left hand. As we couldn't act inside of the thermal envelope and the inner side, so we decided to design a outside this black painting, airtight or airproof painting, which works, I think, quite well. The second photo, you see the testing of the adherence of the EPS insulation on this painting, which was not so clear whether it could work or not. And well, then some other photos. The lower photo on the right hand, you can see the HVAC system. We tried to combine these the ducts with existing windows, so it was not so easy, quite challenging also to perform this for the installer. Here a photo of the floor of the first floor. During the execution, there were some surprises, some beams, concrete beams, which appeared unfortunately, so we had to change during the execution the design of the ventilation system. And even though the photo, I think it looks quite nice, because it was this idea to show to the pupil this kind of gadgets, of technical gadgets, which is part of their daily life routine. But I would not repeat this solution, because we had some complaints regarding the sound, the noise of these machines in some rooms. So it was like a compromise which you have to do. And of course, this was for us also a prototype, so we have quite a lot of learning effect. We had a lot of learning effect on this building. Here you can see monitoring before the retrofits. It's very interesting to see how the blue line is the development of 1 week of in winter time. You see the outside temperatures between 7 and 15 degrees more or less, and you can see how the normal building performs. So the curve is really parallel to the outside temperature. No, this is very typically for these no insulated buildings with very high air infiltration. And then you can see the comparison with one typical week after retrofit. Actually, this was also in beginning of winter without the heating system, or let's say with the heating system switch off. So you can see also a week where we have 7 degrees, 15 degrees more or less, and you can see how constant the interior temperature has been between 20 and 22 degrees. Then we have a lot of data. Of course, the problem, if you make monitoring, you get like millions of Excel lists, and you have to try to filter the really interesting ones. And this is from the last year's monitoring period. As I told you that unfortunately it ended up in no, this was before the retrofit. So you can see the purple line is indicating a very good quality of of the CO2 air quality of the inside, and you can see a clear difference between the typical winter months, which is between December till March, with quite bad concentration, high concentration of ppm during the classes, and then from April till June in these older buildings, of course, the user opened the windows, and in terms of CO2, it didn't have problems on that case. And then after the retrofit, you can see here also the development of it's a more more constant and horizontal behavior of the CO2 through all the months, which I think it's a good result. We calibrated the HVAC, the ventilation machines, so to be in like a range of 1,000 and 1,400. That was our aim. Then the user who preferred to have lower ppm concentration, so therefore I think it's a quite understandable result. Then time out of this is before retrofitting. The time during the lessons, during the lessons of the school hours. So you can see that, for example, February we had 80% of the time, lecture time, below 20 degrees, and then in June we had also quite bad behavior. This is before retrofitting. You can see here it's the same, but with another different kind of graph. And you can see in February, for example, we have to say with the heating system, nevertheless, most of the temperature has been between even 16 degrees and 20 degrees, so it's quite bad result now, I suppose. Then the summer months is April and May. It was not a problem for these months. And then June is a critical month, and before retrofitting, the rooms had quite a lot of days between 27 and 29 degrees, some day with 30 degrees. Here is the comparison after retrofitting. So the green bars are the good performance bars, and we can see that it's a good result. Probably September and also June are critical in after the retrofitting. We have to say that the PHPP calculation already stated that the project was, let's say, above the 10% of overheating frequency. So for certification, it was mandatory for the end of certification, it was mandatory to have an active cooling system, because it was clear that just with passive cooling strategies in this kind of very dense occupied rooms, it was impossible to get into this 10% overheating frequency level. No, this, as I already told you, that this politically is not nowadays possible. So the municipality didn't want to install this active cooling system because of political reasons. You can see here also the development of the temperatures. I have two more slides. I don't know with the time. I think, yeah, we are quite okay. I have two more slides concerning the consumption. This first one is the electrical consumption. So of course, due to the mechanical ventilation, the red bar is after retrofitting, the blue bar is before retrofitting, and you can see that we increased the electrical consumption. So therefore, it's very important to work with very efficient HRV or ERV systems. In this case, it was a certified machine from Czech Republic, quite a good machine, and we could reach a certain balance with changing the lighting to LED lighting. So the final increase of the electrical consumption was about, as I see at the right, about 5% in the sum. Then, and this is the last comparison. This is the energy for heating, the energy consumption for heating during the 4 years before the retrofitting, and then the 2 years after the retrofitting, and you can see the difference. So we have an average of in the 4 years before retrofitting, an average of, you can see the numbers on the right hand, about 56,000 kilowatt hours per year, and then an average of 5,000. This is, let's say, for the main building, which has been retrofitted, because on the side there is also a kindergarten and also a small kitchen, and so therefore you have these different colors. So the color of the EnerPhit building is the light blue color one, and there you can see the change, the difference between the after and before retrofitting. So we had this decreasing of factor 10. So after the retrofit, the municipality is paying, or is consuming this building, in this building, about 5,000 kilowatt hours. So it's factor 10, so which is typical value we know in Europe for this kind of deep retrofits, starting from quite, of course, bad performance of the building, without any, or with very few insulation and bad passive house starting point. No, so yeah, I think I hope, I don't know, I didn't check my hours, so I don't know if we have passed this 15 minutes, or do we have time, or Prudence, you tell me, is it okay? I think this I'm ending. Is it fine, or